Okay, so the topic is virtual machines, and we will cover the following outcomes. Explain what we mean by virtualization. Describe a virtual machine. Explain container virtualization and compare hypervisor approach. Describe what a hypervisor is. Explain input-output management in terms of virtual machines, and describe memory management in reference to these virtual machines. Okay, so what is a virtual machine? A virtual machine provides, okay, an interface identical to the underlying bare hardware. The operating system creates an illusion of multiple processes, each executing on its own processor with its own virtual memory. So a virtual machine is a computer that exists only in a logical sense, not in the physical sense. Okay, so it's more of a emulated machine. Okay, and we use software to do so. We use software to emulate or create a virtual computer on or within another computer. And we virtualize these common resources, which we're going to talk about later on. So common terms we normally use when you're talking about virtual machines. There is the host. So the host is the computer, the physical computer that we are using to create other virtual machines. Okay, we refer to that as the host. We have virtual machine manager or hypervisor, creates and runs virtual machines by providing interface that is identical to the host. So this is the software, the abstraction, or we call it the abstraction layer. So this is the software where everything happens, where we dynamically assign or we assign resources to our virtual machines that we want to create. We use a special software, and that software can either be called a virtual machine manager or a hypervisor. Okay, so we're going to talk about we're gonna expand on hypervisors later on in the presentation. Okay, so host, virtual machine manager or hypervisor, and guest. What is a guest? Process provided with virtual copy of the host, usually an operating system. So if physically the operating system you are running on your computer right now is the host, then the ones that you install on the virtual machine would be the guest operating systems. Okay, so the virtual machine then would be a computer it has all of its hardware emulated from the resources of the host. Everything is borrowed from the host. And what you need to remember is that if you are running a 32-bit processor on your host machine, then your guest operating systems would also be limited to 32-bit. Okay, if you are hosting a visitor, you can imagine they're probably going to have the same privileges as you. You're not gonna treat them like royalty. So it's not possible to have a guest operating system operating at 64-bit when the host operating systems is only operating at 32 bits. They have to be the same. However, if you have a 64-bit host, then your guests can run also in 32 bits. But I can't imagine why anybody would want to run an operating system in 32 bits when you can just run it in 64 bits and it's going to be faster. Okay, so then what is virtualization? We say virtualization is an abstraction layer that decouples physical hardware from the operating system to deliver greater IT resource utilization and flexibility. It allows multiple virtual machines with heterogeneous operating systems to run in isolation side by side on the same physical machine. So maybe you're curious about a particular operating system out there, but you do not want to format your hard drive, nor do you want to partition your hard drive. Okay, because you have those options. You can either you want to use Explore Linux, then format your current computer and put Linux in there. But then you realize, no, I still need this data on my computer. And what you do then is you can also create a partition, a separate partition where you're running these two operating systems that you want to explore in parallel on the same computer. But that is not virtualization. So virtualization is an alternative where you still keep your data, you still keep your current operating system, you don't format it at all, you don't partition anything, but you use a hypervisor to create a layer of abstraction where it emulates your computer hardware to create as if this computer was a standalone computer, but it's more existing in a logical sense. So in terms of virtualization, each virtual machine has its own set of virtual hardware. So it'll have virtual RAM, virtual CPU, a virtual network interface card, upon which an operating system applications are loaded. The operating system creates the illusion of multiple processes, each executing on its own processor with its own virtual memory. Okay, so if we let's take an example where you are trying to create a virtual machine and your computer has about let's say your computer has 4 GB of RAM and your CPU has multiple cores. So you're using a multiple core CPU. Most modern CPUs have more than one core. Okay. Let's say you have a dual core processor. Okay, it has 2 cores and a network interface card. So according to your RAM, it's only 4 gig. Now, you got to understand that your host would need to reserve certain parts of that RAM for itself, to be able to operate at its optimum level. So once you create your guest, you can only give it a certain portion of that. Maybe the hypervisor would advise you to say, don't allocate more than 60%. That is the actual rule. Don't allocate more than 60% of your of your actual host's resources, because then your host is going to start to lag. It's going to start to slow down. It's not a problem to allocate 60% because the virtual operating system, when it's running in the background. Okay. However, if you're allocating everything, then you still need the host to have something left. Okay, it's running its processes, it's doing some tasks for the actual guest operating system. You may not even see it, but it's doing some tasks for the guest operating system, in the sense that when the guest needs a resource from the host, it has to be able to respond to it. When it needs swapping or virtual memory, it needs to be able to respond to it. So if you leave nothing left for it, it's not going to be able to serve the guest. Okay, so the rule is not more than 60% of your RAM. In terms of your CPU, not more than half the cores. Okay, but I mean, if you have a dual core, then you can only give half. So you give one core you leave one core to the host, and then you give one core to the virtual machine. And with the network interface card, that is shared in a virtual manner. You can either bridge it, and there's different ways. And I'm going to take you through one of the softwares used to create virtual machines, and you're going to see how we go about reserving all of these hardwares for virtualization. So this concept of virtualization originated in the 1960s, okay? And it says virtualization was first introduced in the 1960s to allow partitioning of large mainframe hardware. In the 1990s, researchers began to see how virtualization could solve some of the problems associated some of the problems associated with the proliferation of less expensive hardware, including underutilization, escalating management cost, and vulnerability. Okay, so this concept of virtualization actually began in a more of a hardware sense. So they had actual virtualized CPUs, multiple CPUs, to run the guest operating systems individually. And then they had a firmware which allowed these guest operating systems to share some of the resources. So when virtualization first emerged, it was more of a hardware solution with a bit of firmware. Now it's the other way around, in the sense that the hypervisor or the software is the one that's in charge of managing all of these resources and ensuring that the virtual machines receive a fair share of the resources. And there is only one physical box, there is only one physical CPU, and the hypervisor is the one that's going to be dedicating the cores to all the different guest operating systems. So now it's more of a software-based solution more than anything. So we then refer to the virtual machine monitor as the operating system at which the virtual machines are running on top of. And again, this could be an operating system altogether, or it can be a software-based solution. And you're going to see later in the slides that follow what I mean by that. Is you can create a virtual machine by removing the layer of the host operating system. Let me just see if, okay, it's not the next slide. So the virtual machine monitor, we know what a monitor is. It's a lightweight operating system used to create certain functions. And in this particular case, it will be a lightweight operating system used to create virtual machines. So we're going to leave it there for now. And the architecture of a virtual machine would look something similar to this. Okay, we would have the hardware, we have the kernel, and we'd have the processes running on top of that in an event where there is no virtual machine. And under normal circumstances, we have our hardware, we have our kernel, or what we call our operating system, and then we have our processes, our softwares, our applications that we run. Okay, but in a virtual machine setup, we have hardware, okay, virtual machine implementation through some sort of specialized hypervisor or through some sort of specialized software for creating virtual machines. And we have virtual machine 1, which could be Windows, virtual machine 2, which could be Linux, virtual machine 3, which could be Mac OS X, okay? And I can, if my computer has enough resources, I can run all of these simultaneously in the background, just like how I would do with PowerPoint, Microsoft Word, and Excel. I can run them in that manner, but it's different operating systems running virtually. So that's the beauty of it. But you need a lot of resources in the host computer to be able to do that without experiencing. Most of the time, most people will only be able to run 1 or 2 virtual machines before they start to experience resource allocation issues. Okay, so a hypervisor, we say it's a operating system or a software to create virtual machines. And there's 2 types of hypervisors. There is type 1, 2 main types that we're going to learn about. There are other types like type 0, where earlier on when they said in the 1960s they used a firmware. That's an example of a type 0, where the virtualization in the type 0 was more of a hardware solution than it was a software solution. So type 1 and type 2, it changed and it moved towards more software solution virtualization. So we have hardware still, okay? Then we have an operating system called a hypervisor, which is installed directly to the hardware, okay? And it can create guest operating systems, right? Here, okay, let's first talk about type 2 before we compare the two. So we have type 2 hypervisor, we have the hardware, we have the host operating system, okay? Then we have the hypervisor, then we have the guests. So what does this mean? It means that you are on some sort of general purpose operating system like Windows or Linux or whatever, and you are using that platform to run a special software to do virtual machines or to create guest operating systems. So in type 2, the virtualization or the hypervisor is more of a software-based solution, as opposed to type 1, where it's an operating system altogether by itself, and it has direct access to what? To the hardware. So then we can say that type 1 hypervisor is the one that is going to be faster. Why? Because the hypervisor itself is not sharing the hardware with anything. But if you look on type 2, the hypervisor is sharing with what? It is sharing the resources with its host OS. So basically, we have 4 gigabytes of RAM, which is shared by the host operating system, it's shared by the hypervisor itself, and then it's shared by the guest operating system. So you can see which ones would definitely be better between the two. Okay, so this is just a table that is doing the comparison, and it's saying that if you're running hypervisor type 1, type 1 hypervisor has got better performance than type 2. This is because it does not compete for resources with an operating system, since there is no host. Okay, it is more secure than type 2 hypervisor. Okay, it is more secure than type 2 hypervisor just because it's an operating system altogether. And you can imagine in a type 2 kind of situation where the host is infected with viruses, which means we lose all our guests. Okay, a server is mainly dedicated to a particular function, and then in type 2 performance, comparing with hypervisor type 1, poor performance due to the compete of resources with an operating system, which is the host. It is less secure. No need for dedicated server to one function. The virtual machines that are created and used can be migrated or copied from one hypervisor environment to another, reducing development time, increasing the accuracy of what is deployed. So at the same time, with the type 2 hypervisor, it's easier to copy virtual machines between computers. So if I have a laptop here, and on my laptop I have all my guest operating systems, and I decide to buy a new laptop, it means I can just simply put in a flash drive and copy all my, because they're software based, it's files, extensions, software based things. So I can copy my virtual machines onto a hard drive and then paste them into the new operating system on the other laptop. Okay, so para virtualization. So we can have full virtualization, or we can have para virtualization. So we say para virtualization is virtualization in which the guest operating system is aware that it is a guest, and accordingly has drivers that instead of issuing hardware commands. So in a para virtualization setup, I would say it's commonly used with type 2 virtualization. Because in type 2 hypervisor setup, there is a host, and the guests know that they are guests for the mere fact that they have to install drivers to make use of input-output storage. They have to make use of drivers to access the network interface card. They have to make use of drivers to multitask or multi-program the CPU. So in a para virtualization environment, you find that everything is driver driven. The guests communicate with the host operating system through what we call drivers. Okay. In a fully virtualized environment, it's more of hypervisor type 1, where there is direct commands, hardware commands being issued to the operating system, like how a host would do to hardware. Okay, so there's direct interaction because we have the hypervisor there without the host operating system being present. Okay, so then we have this concept of memory ballooning, which happens a lot when working with memory and there isn't enough memory, especially in the case where you're running guest operating systems. So if I have on my computer three guest operating systems, so whenever because simultaneously I can only run one, although I can launch them all at the same time, but I can only run one at one given point in time. So what will happen is that although I only have 4 gigabytes of RAM, and 1 gig is reserved for my, let's say 1 gig is reserved for my host operating system. And then I said, guest A will have 1 gig also, guest B will have 1 gig also, and guest C will have 1 gig also. So if guest A is not running, then it will not use that RAM anymore. It will only use it when it needs it. Okay, so it doesn't mean just because we are allocating you that RAM that now it's fully reserved for you and nobody else can use it. Okay, so we refer to the concept of as ballooning because it only, those resources, it only takes it when it's running. In this particular case, you can see that the balloon is inflated in guest OSB because it's the one that's currently running now, which means it will sort of, hey, you allocated me these resources, I need them now, I'm using them now. When you shut down that virtual machine, the that balloon will sort of deflate. So we have this concept of inflating and deflating the allocated resources. Okay, so some of the benefits of virtualization: partitioning. Multiple applications and operating systems can be supported within a single physical system. There is no overlap amongst memory, as each virtual memory has its own memory space. Okay, so again, there's this concept of partitioning without actually partitioning, which is good because this is happening in a logical setup. I don't have to physically partition my hard drive to achieve this task of having multiple applications and multiple operating systems. Isolation. Virtual machines are completely isolated from the host machine and other virtual machines. Okay, and then again, if we're looking at a full virtualized environment versus a para-virtualized environment, we can say with the para-virtualized environment, isolation is not 100% complete, because these guest operating systems still meet where? They still meet at the host. Some way or the other, they are colliding at the host. But if you're comparing with the type 1 or full virtualization, there we have actual full isolation where there's no possibilities for impacts or any collisions between the different guest operating systems. So if a virtual machine crashes, all the other are unaffected. Data does not leak across various virtual machines. So regardless of whether you are using full virtualization or para-virtualization, if one of the guests crashes, it doesn't affect the other one. Yes, they may compete for resources in a para-virtualized setup because they are all meeting, or these drivers are sending requests to the host operating system. But if one crashes, and we do not lose our data on the other. Host systems protected from virtual machines protected from each other. A virus less likely to spread in this manner. Sharing is provided through via shared file system volume network communication. So when you want a hard drive to be shared, remember that we have our physical hard drive in our host computer, and then we dedicate maybe 40 gigs to one guest, then another 40 gig to another guest operating system. So there will not be direct communication between, they're protected from each other. The file systems are protected from each other. So guest B would not have direct access to the hard drive of guest A. But there is a way of having them all create a shared folder in the host host's hard drive, and each of those guest operating system can have access to the shared folder rather. So this is facilitated by the host, where it's the intermediary between these ones. So they do not, we want isolation, so they do not have direct access to each other for security purposes as well. Okay, so we can freeze, suspend any running virtual machine. We can clone them as well. We can do various things with these virtual machines. So if you feel like, I don't want to use Windows today, I just want to run Mac only, you can suspend it, you can freeze it. Okay, and then the concept of ballooning, the balloon will deflate because now you suspended it and it's no longer occupying those resources, and those resources can be used by another operating system that you are running, or they just default back to the host. So in terms of server machines or server environments, virtualization is a very beneficial concept. Okay, so let's hear some of the benefits it brings to a network or server. More efficient use of server resources. Dedicating one server application per computer is the most reliable way to provide services, and it's more maintainable as well. Okay, so instead of me dedicating one physical box for a web server, one physical box for DNS, one physical box for DHCP, I can run them all on one physical machine, but in a virtualized manner. So these machines think they are dedicated, but they're actually not. They're actually still sharing one sort of hardware. You still, what you achieve there is more efficient use of resources, because if you are doing it in a physical manner, this concept of dedication, it's definitely going to cost you a lot of money, where you find that the web server is only being used by 30 or 40 people in the organization. Yet we have it as a dedicated box, as a dedicated physical box. It's a waste of money. It's a waste of resources. Ability to run operating systems on a single computer. Okay, we already mentioned this. The fact that you can have a mix of XP, Linux, Windows, whatever, all of these different operating systems. Ease of moving virtual machines. Okay, virtual machine becomes a file, especially in a type 2 hypervisor. Just copy and paste the file. It's as simple as that. And then the configurations on the other end will kick in. Reduced power requirements. You can reduce the energy required to run your IT infrastructure by consolidating servers. Your power requirements are reduced. So you actually lowers your electricity bill as well, because if you have physical boxes, a server is always running 24/7. It must not be down. If it's down, the service goes down. So by dedicating physical boxes, you're using so much of electricity, but you can still achieve the same concepts of dedication in a virtualized environment, and you're saving electricity because only one physical box is connected to the power. Simplified maintenance. When you put a lot of applications on a single server operating system, it becomes difficult to maintain each individual application without affecting the others. Okay, so again, whenever a virtual machine is giving us a problem, we can just simply suspend it or freeze it. Okay, and it won't affect the others. It won't affect the others, and we don't have to, if we are running this server setup on a physical box, then we have to, because one service is not working properly, now we have to restart the server, and all the other services in our network would also be down or impacted. Okay, so that's the beauty of it. Simplifies this aspect of maintenance. You can isolate the problematic partition. So again, we find that there's going to be some sort of vulnerabilities when it comes to using virtual machines, especially if a particular guest is compromised. Then that attack or virus can then filter to the hypervisor, and then you are in big trouble, because that vulnerability can move from guest 2 to the hypervisor, from the hypervisor to guest 1, and to all the other guest operating systems. So you're still vulnerable to attacks, and because you are running your different services in one physical machine, then all of them will be infected for as long as the host or the type 1 hypervisor is infected with the virus. So you have an alternative. If you do not want to deal with all the difficulties of type 1 and type 2 hypervisors in creating a virtualized environment, then just use the cloud. It's as simple as that. You are using the cloud, and the virtual environment is more of a cloud-based solution. So all of these hypervisors and guest operating systems will be done for you by the cloud service provider. So it removes the need for any type of hypervisor, whether it be it software-based or be it OS-based hypervisors. Okay, so Also, I just want to conclude the lecture by showing you a typical software that you can use to create virtual machines. Very common. It's called VirtualBox. Okay, it's free. It's owned by Oracle. Anybody can go on the internet and download it. Okay, and then you can use it to create virtual machines on your computer. So let me just demonstrate briefly how this actually works. So you go on VirtualBox, you download it, you double click on it, you install it. And part of its installation is installing drivers. Why? Because this is a type 2 setup. Okay, this is a type 2 setup. This is not a direct hypervisor, but it's more of a software-based hypervisor. And you can see that I'm running, because you can see my desktop, you can see I'm running a host operating system. So my Windows then will then become a host, and then this will become, VirtualBox will become the hypervisor. Okay, so this is a type 2 kind of setup, which means VirtualBox, my host operating system, and the virtual machine that I want to create will all be sharing my computer's resources. Let's call this test guest. Okay, so you need to provide your virtual machine with a name. And then you select the type of platform at which you are installing for. Okay, you can see you have a lot of options. I'm surprised now eventually they included Mac OS. I don't know how they were able to achieve that, because earlier versions of VirtualBox, you could not do this directly without doing some sort of hack. Apple is very strict with their software. They don't want it running anywhere else besides a computer with the Mac or Apple logo on it. So let's say we were trying out or testing Linux. So we click on Linux. Okay, and then now it's going to ask us, which Linux do you want to create as a guest? And you see all of the different editions are here. These are the different distributions of Linux. So let's say Fedora 64-bit. So my CPU on my computer is a 64-bit based CPU. So you can see I have the options of configuring both. But if my CPU was only 32 bits, I would only see these options for 32 bits guest operating systems. So let's say want to install Fedora 64 bits, and then I click on next. So now it's going to ask me, based on the resources on your computer, how much do you want to allocate to this guest that you are creating? Since we're talking about Linux, I don't really think I have to allocate it that much, but let's try and see in a situation where you are installing a different type of operating system, which requires a lot of RAM. This VirtualBox is good because it gives you advice. Everything in green is good, which means you can allocate up to the green part. Once you go over green, okay, orange and red, you're now playing with danger, because it means you're taking up, look how much RAM you're taking up from, if I put here, it means I'm only leaving 1 gigabyte for my for my host operating system, which is not a good idea. So they're recommending that I only give roughly 5 gigs to my guest. Okay, I accept that, and then I move on. I click next. So now it's going to ask me the recommended size of the hard disk is 8 gigabytes. So what it is saying is, we know you're going to be installing Linux, and the Linux itself is going to take up certain space on the hard disk. So at least put 8 gigabytes of disk space, but you can add more, you know. So I can say something like, I can use an existing a virtual hard disk if I'm moving a virtual machine to this computer. Okay, if I already have an existing virtual machine, remember I said it's as simple as copying and pasting to a flash drive. I can use this option of use existing, but I can say create new hard drive in this particular case. Okay, then you just leave that by default and you click next. Then you say Dynamic, yes, next. Let me see. So you see, I have the option all the way up to 2 terabytes, but I mean, it's just Linux. Why would I want to give it anything more than 8 gigabytes? Then I click next. Okay, so now my virtual machine has been created, and the name of the virtual machine is test guest. Okay, and these are the specifications of test guest, right? And then in this particular case, I can't click run for the main reason that I did not configure an ISO. So once you reach this step, it's the first step where you're allocating resources to your virtual machine. The next step is to access its settings. Okay, you access its settings, and you can see so many settings here. It's as if it's a real computer. Storage, audio, how do you want the audio to be set up? How do you want the network to be set up? You can see devote multiple adapters, but leave all of this stuff by default. You've already done the configuration. You don't need to play around with any of this stuff unless you really understand what it's doing. Okay, and remember the shared folder I talked about earlier on, that because the guest operating systems can't access each other directly. So I can add a shared folder here somewhere on my computer, and then when I'm running the guest operating systems, they would both have access to that shared folder, so it'll be showing there. And then there's different settings and so forth. So once you've done the initial stage, then you need to come here and add a new ISO. Okay, so you pick a disk, or you can choose a disk from a file, and it will allow you to select an ISO image file of an operating system. In this particular case, remember we said we were installing Linux. So then I would need to browse my computer for where the Linux is, and it will show here, and then I click OK. Once I've done that, now I can start, because what I've basically done is like taking a Linux disk and putting it inside my computer now. That's exactly what I've done. Now I can click start, where previously, if I just clicked start, we don't understand. There's no disk. What computer are you launching? There's no disk. There's no operating system at the moment. Okay, so I did not link it to any ISO file, as you saw, because I don't have a Linux ISO file on my computer. But if I did that, then if I click start, then it will run and it will start the installation process for Linux. Okay, so it's just going to show me a lot of errors and stuff like that. So I'm just going to suspend this machine, pause it, and then suspend it. Okay. So if you had, you can see, you can have a long list. I can even create a new one, and then you can have a long list of guest operating systems, all based on how good your computer is and how many it can handle. Okay, so that is the unit covering virtual machines. Okay, I'll give you guys an opportunity to ask questions.